All right. So this is stuff I wrote for the Flare VM, although you can do it on other machine if you install the right tools. To make the Flare VM, you have a Windows machine and you just run this script. You download this script from GitHub. You get a Windows 10 machine, like a trial version or something, and then you go here and download this script and run it. And it takes a really long time. Anyway, once you're done though, you have this Flare VM machine to use. And what I wanted to show you first is, I guess I'll just talk through a few of these because we're going to get to DIL hijacking, which is very nice. All right, so first you unpack things. This is the generic technique to unpack a file that is packed with UPX. This is a way to do it without making a custom version of UPX like I talked about before. This is a famous technique. So you have a file, and this file is packed. You can just compress a normal file, and now you can decompress it. Now, if you use PE Studio, which is a fantastic tool, another free tool, this tool gives you a nice malware analysis right away. It analyzes a file, it looks for indicators of malicious activity, it sends it to virus total, it lets you see the sections, and it's very nice. And so you can see all the sections, and you can see the entry point, and you can also see the entropy of locations. This entropy of 7.8 means this is almost completely random, this compressed file, because 8 is total randomness. And you see lower entropy for normal sections. Like here, this is a non-compressed file, an executable. And so the text data section is 6.6, which is highly random, although not totally random. And that is assembly code, because assembly code is these assembly language commands that are pretty much random. Here's data, here's probably strings or something. It's not very random at all, entropy of 2, and here's resources, that's probably images or something. And so that's what you normally see. Entropies above like 7.5 are usually compressed data or encrypted data. All right, and notice the names of the sections in the original uncompressed file are normal: text, data, rdata, and resource. But the compressed file with UPX now has UPX0, UPX1, and resource. And the entropy is 7.9 here. And this section is all zeros. You have an empty section, and you have another section that is totally compressed. So what's going to happen is when you run it, it's going to uncompress this and build the actual executable section from it. And you can watch that happen in Ollie. And if you look at the imports, which are right here in PE Studio, it'll show you what functions are called, and there are very few functions called. By the way, it will also tell you if they are functions that they look suspicious, and they'll even give you MITRE attack techniques that match it if they are recognized as things like these things are associated with tactic 1106. And it doesn't mean that this is malicious. And of course, PuTTY is not malicious. It's just an SSH client, but it has a couple of function calls that look a little fishy. And that's pretty common. A normal harmless piece of code will have some suspicious features. All right, then if you get the malware samples, you can look at them. And you'll see the same kind of thing here. This is a UPX compressed file. So you have a null section that contains nothing but zeros. Then you have a highly compressed section with an entropy of 7, and another section that can be something less compressed. So now if you open it up in PuTTY, open your compressed file, it's going to notice that it's compressed code, but you can analyze it anyway. And you'll see that the original uncompressed PuTTY starts with push 60 and then does this. But the compressed code starts with push AD and other things, because what you're seeing is not the PuTTY code, you're seeing the decompressor. And the decompressor in UPX is in fact very simple. All you have to do is scroll down a bit and you'll see the end of it. It's really only a couple of screens of assembly that does the decompressing. All right, and so what you can do is view the unpacking stub. You'll see it go through some code, and then at the end, it will jump. So you can actually run it in PuTTY and watch it go. You can dump the contents of memory here, and you'll see it be 0. And as you run it, it will fill in the code as it unpacks it. So you can run it until it's finished unpacking and then put a breakpoint and stop with the decompressed code in memory. And from OllyDebug, you can then write that back into a disk file. So you can manually decompress it and save a decompressed file. This is the standard technique to decompress Olly code. So you use this thing called Olly dump, and you have to make sure to fix the start address. So it's a go to the correct start address of the unpacked code, but you can end up with code that you can analyze in IDA anyway. Now, when I do it, I don't usually end up with code I can actually run because there are other defects, but you do get a much closer version of the file. And now you can see all the real Windows API calls, all the strings, and you can analyze the flow in IDA. So that's the general technique to decompress things that are hard to decompress. And this, by the way, is true of almost all malware. Any malware that has some kind of packing or encryption routine, usually the easiest way to defeat that is to run the code that's in there that decompresses it and just stop after that, and then get the code that's created. So that's manual unpacking, and I think I'll stop and make a separate video about the DILs.